Hello. In this episode, we'll discuss about the causality issues in regressions and how to remedy it. And we'll discuss about a particular technology called differences in differences. So here is the motivation for what seems to be the issue with linear regression. So here's an example of a linear regression which tries to explain the violent crime in terms of several social variables, one of them being the police per capita. And the estimate here is that, well, 0.562, so whatever the law police per capita is, 1 unit of increase of that will increase the violent crime related to higher violent crime, 0.562. Okay? And it actually is statistically significant that the standard errors are 0.056. Right? So does that mean that the larger police force caused more crime? That's really strange, isn't it? Why would you increase the police force if it causes more crime, isn't it? So that's the limitation of the linear regression. It can tell how violent crime and police force are related, but it does not say police causes violent crime or crime causes police large police force. And probably the more plausible scenario would have been that because there's violent crime, the city needs a larger police force. That's probably more reasonable explanation, but the regression by itself doesn't tell us which direction it goes, isn't it? The linear regression can tell only whether two variables are positively or negatively related, like a correlation. It cannot tell whether one caused the other. So then how do we show if we want to establish a causal relationship between two variables? And here's one idea that came in 1994 by two economists, Card Krueger and David Card. They take the inspiration from clinical trial in medical science. And here's the usual idea, like coronavirus drug development. What do? When we develop a wonderful drug and then want to show that it actually has an impact, how do we do this? Well, we take two guinea pigs, okay, like what we call control group and treatment group. The treatment group is where we want to actually show the effect of the drug. So what do is that we take these two groups and then give a placebo, like a fake drug, to this control group. And this is just as a benchmark, the baseline in the effect of no effect drug, what would happen and how the guinea pig would behave, versus the treatment group, where we actually give the real drug, isn't it, and see the effect. Okay? And then medical scientists try to show that, oh, there's an effect here, but not here, so this drug works, something like that, isn't it? So the economists take an analogy to this, and what they do, they don't have a drug, but what they do exploit is that they exploit a sudden or surprise change in the economic environment, like a state law changes for something, and that impacts the subset of the economic entities like firms or taxpayers or something like that, and show that, wow, this policy change does have an impact. And so that's how they show it. It is very important to know that I said subset of economic entities, meaning you do need to have a control group that does not go through this experience and have a subset that goes through this experience. And by showing that only this group goes through this experience, you can meaningfully say that whatever the test drug or this change in economic environment was had an impact, because the other group that didn't go through did not have an impact. So here's an example of how we do, and some minimum wage increase in New Jersey that happened in 1992. Okay? And there has been and still is a long debate on the minimum wage increase, that if we increase the minimum wage, it helps the people who need more income. That's a well-intended policy, but also the counter argument would be that if we increase the minimum wage, stores cannot afford it, and then they will have to fire people, especially people who rely on minimum wage, isn't it? So which way does it go? It's kind of difficult to argue, and it's a very important policy debate. So here is what David Card and Card Krueger did. Basically, notice that a situation where there were a local economy on the borderline of New Jersey and here the eastern part of Pennsylvania, they used to have the same minimum wage, $4.25. Okay? But after April 92, only New Jersey raised the minimum wage to $5.05, which is a significant increase. And then they look onto, does the increase of the minimum wage impact the employment? Does it reduce the employment? Does it keep remain the same? Okay, it's an interesting thing. So this is sort of like, if you will, similar to this situation, isn't it? Here is the test drop. The minimum wage was increased, whereas this neighboring, so this is the control group, which didn't increase, and only the New Jersey, in our case, the treatment group, increased the minimum wage. So how does it impact the increase of minimum wage, increase the employment? Okay, so that sounds a good start. So how do we measure this net impact on the employment? Okay. So here's one idea. Change the New Jersey employment before and after 92, meaning, after 92, the New Jersey minimum wage got increased. So how about we compare the New Jersey before 92 and after 92 employment and look at the differences here. Sounds like a good idea, but there's one concern. There's a temporal macroeconomic effects, meaning between the before 92 and after 92, maybe there might be a time trend that the whole macroeconomy must have changed. So the minimum wage and employment, the employment may have just changed because the macroeconomic condition changed, isn't it? How do we disentangle from just the New Jersey policy change of the minimum wage and not the macroeconomic condition? Okay, so here's another idea. How about we compare the Pennsylvania after 92 and New Jersey after 92, because only Pennsylvania remains the same and only New Jersey increased it. So maybe the employment is higher here than here. Sounds like a good idea too, but here is the problem. There might be a geographic effects that Pennsylvania firms may be systematically different from New Jersey firms. So it may be just the difference in Pennsylvania firms are different from New Jersey. Having said that, to be fair, Card Krueger's experiment, they only look at the fast food chain restaurants like Wendy's, McDonald's, Burger King, and so forth. So they're kind of homogeneous industry, but nevertheless, there might be a Pennsylvania effect versus New Jersey effect, and you cannot distinguish whether the difference, if you ever observe, would be in employment. That would be because Pennsylvania is special than New Jersey, okay? Not because New Jersey increased the minimum wage. Okay, so what do we do? So here's the third idea that is inspired by this natural experiment, and that is difference in differences. So here, what do we do is that, well, we do observe the employment difference when Pennsylvania and New Jersey had the same wage, minimum wage, isn't it? So look at the employment difference. We call it New Jersey minus PA pre-92. We also observe the difference of Pennsylvania and New Jersey after New Jersey increased the minimum wage. Let's call it New Jersey minus Pennsylvania post-92. Okay. So here's the gap between New Jersey and Pennsylvania before the minimum wage increase, and here's the gap before and after Pennsylvania, after New Jersey increased the minimum wage. Let's take the difference. Look at how these differences, these gaps are different, isn't it? And that measures the net impact because it actually cancels out any time the macroeconomic shifts, isn't it? Because the New Jersey and Pennsylvania before and after, so the macroeconomic effects are canceled here by taking this time difference, but also the New Jersey, Pennsylvania, the specific differences are the Pennsylvania. If there are Pennsylvania specific effects, they are canceled out. The New Jersey specific effects are also canceled out, isn't it? So it cancels out the temporal and geographic effects, and only the New Jersey minimum wage effects are remaining. Right? And that's how we claim that how much the New Jersey minimum wage increase impacted the employment. Okay. So here's the actual results. Okay. So, and what they find is that, well, the Pennsylvania had before 23, whatever the units were, and New Jersey 20, okay, and the difference was minus 0.29. Afterwards, it was 21 and 21, so the difference is fairly small. And taking the difference off the gaps, will get you 2.76. Seems like a positive number, but if you look at the standard error, 1.36, It's kind of barely. Okay? So it's not that much of a strong effect that you would claim. Okay? How do we actually run it in a regression? There are two ways of doing it. Okay. The first one is that you take the difference of a store, let's say a Wendy's in New Jersey or a Burger King in Pennsylvania. So I indexes each store. Okay. Take the difference of the after and before and call it delta EMPI. Okay. You regress it on a constant term and a New Jersey indicator. If the store is located in New Jersey, have a 1. If it's located in Pennsylvania, have a 0. Okay, so that's what we call a dummy variable that indicates whether a store is in New Jersey or not. If you regress on it, and then the estimate here picks up the difference and difference estimate. Alternatively, one could go a little bit more sophisticated. You have an indicator for each store. Each store will enter twice in this data. The Wendy's in New Jersey for that particular location before 92 and after 92. Okay, so it enters twice. Here's a store fixed effects. If it's a particular store, then have that on. Okay, so there are a whole bunch of AIs, it's the alpha I's. And then you have a post-92 indicator, which is if that store, the measured employment is after 92, then have it 1, if not, 0. And likewise, if that store is in New Jersey, then have it 1, if not, 0. Okay, and then multiply these two indicators, the post-92 and New Jersey indicators for that store in that time, okay, and have it regress. This interaction term, which is the multiplication of the post and the New Jersey, okay, the estimate on that will pick up the same estimate as this one here. Okay, one could econometrically prove it, and you should take econometric classes for that. But let me just take that. It will give the same number. Okay, it picks up the difference and differences effect. Okay, so that is a quick review on the difference and differences, how it's used in the context of minimum wage. Let's take a brief look at how it's being done in Python. So thankfully, this data is being provided by us from Card Krueger minimum wage. You can just web search it. Card Krueger minimum wage data. Okay. And here available data sets. So Professor Card kindly at Berkeley provides us with this, and here's the data set. Okay, so maybe I should copy this here. That's the website. And you could download it. If you click here, the data set, it will download it. Okay, njmin zip. Okay, so let me just upload the statistical packages. Remember, Stats Model API, nickname it SM, is the OLS linear regression package. I'm uploading the data. Actually, it's a zip file. So you need to open the zip file and unzip it and have the public data. Okay. Okay. Actually, two versions. One is called public, and what it does is that each store, so this each store has a unique number and it enters once. Okay, and there are two employments: employment 2, full-time PT and part-time PT2, and employment part-time or full-time before 92. Okay. Also, there's an indicator whether a store is in New Jersey. Okay. I guess, let's see. Okay, here the state. The state variable is 0 when it's in Pennsylvania and 1 if it's in New Jersey, right? And that's what we need, isn't it? So let me just choose the file public. And I'm going to put it done. Okay. So here, as I said, I'm going to keep everything except what we need, the employment full-time before 92, after 92, part-time before 92, after 92, and the state, which is 0 if it's Pennsylvania, 1 if it's New Jersey. I'm going to just put it in these variables, EMPFT, and eventually I'll just call the total employment, EMP1 before 92, EMP2 after 92 employments, add them up. And then DEMP is the difference between before 92, after 92 minus before 92 employment for each store. Okay. I'm going to use the NumPy. So NJ, the New Jersey variable, is the state. Okay. 1 if it's New Jersey, 0 if it's not. Okay. And I'm transposing it. Just OLS likes to have it in a flipped form. All right. So the difference and difference by the first difference method. So Y variable is DEMP. It's the difference for each store in the employment before and after 92. And my X variable is NJ, the New Jersey indicator. I'm adding a constant, the SM add constant, call it X2. Now it's the same as before, isn't it? As OLS, Y, and X2, run the regression, and I'm going to fit it and get me the summary. And here you can get the R square. It's actually fairly poorly explained regression. But the estimates here, what you get is 2.44 in this case. Right? And the T statistics is 1.8, which means that it is not significant, meaning the impact on the minimum wage increase on or change in the employment is kind of not statistically significant. So the impact is kind of small. I could alternatively run it in a panel data, and I have what we call public 2. Okay. So the public 2 is where the entries enter twice. Each chain restaurant, the sheet, enters twice. Okay. And so there's a state variable. So this happens to be New Jersey. EMPFT and PT remains the same. Okay, so I added them up here. And the New Jersey variable is 1 here. Okay. All right. Okay. So that is we need. So load the data, public 2. And now the EMP is the employment, NJ is the New Jersey, post is the post event. So the same store employment data enters twice, once before, once afterwards, isn't it? And we control for each firm. So have a firm ID to have a firm fixed effects. Again, I'm converting everything to NumPy. The difference and difference indicator, remember, you need to multiply the post with the New Jersey. So let's create that. Post multiplied by NJ and call it DD, the difference and differences estimator. Okay. And then I can run it. The Y variable being EMP, the X variable being the DD, NJ, and post, and add a constant, and then fit. I will get, well, 2.44. This is the difference and difference estimator, which is the same as before. As I said, the first difference and the panel regression gives the same estimate. What's probably different is the standard error. It is kind of 2.2, marginally significant, still not too large. If you control for other factors, in fact, it can turn out to be less significant. Okay. Anyway, so this is how to show in Python how to run a difference and difference regression, both in first difference approach and in panel regression. Thank you for watching the video.